So last year at this time, or when I taught this, was supposed to teach this lesson, I was, it was, you guys probably remember January, I was out with COVID for like 10 plus days because my family got sick, which meant at that point in time, I still had to stay home. And then I, of course, got the lovely parting gift of getting to stay home longer because I finally got it. So, um, anyways, so what I did for BC, even back in COVID years, I never recorded the lesson. So I'm working on it right now, but I have guest teacher in there. That just means that the notes I borrowed, the guy that I borrowed the notes from, he has a YouTube channel too, and he did the lessons. So it's there. If you want to listen to him, he's really good. If you watched any of the videos last year at the end, like the review videos, it's Tony. Oh wait, he only does BC. You haven't seen him yet, but he's really good. He actually got me. Tony and Brian got me through like the beginning part of the pandemic. It was great. So I got up at 6:00 in the morning to watch them. It was so exciting. It was really sad that I was watching calculus at 6:00 in the morning instead of sleeping in, but that's what I did. All right, let's talk alternating. I had another BC student who got up with me, and we watched together and texted back and forth at 6:00 in the morning. She passed the test. She got a 5. So, all right. So we're talking alternating series test. We have to determine if it converges or diverges. Okay, which is the name of the game with all of the series tests. What I want you to do is read through that page, the whole page. Okay, except for until you hit example 1, read through the page. Okay. About 30 more seconds to read through it. Okay. So just a side note off to the left there, that's good old Leibniz. He and Newton were the two that battled over the who invented calculus first. Newton probably invented it first, but he refused to publish it because he was stubborn. And Leibniz published it first, and then Newton got all mad. But Leibniz, it also notes in here, actually came up with this alternating series test. That's why his picture's off to the side. So if the dy dx notation, I think that's good. We've did lots of Leibniz today. Dy dx notation is Leibniz versus the y prime notation comes out of what Newton was doing. So, all right. We have yet to deal with, we've only talked about positive terms in a series. Okay. It is possible that our series alternates terms. And we saw that a little bit when we were talking about just creating series. So you'll notice that we've got that -1. It either goes -1 to the n or -1 to the n plus 1. Sorry, this is Ballard. Mm-hmm. Yeah. Yeah. Right. You gotta go up and see Miss Ann. Let me write you a pass really quick. She said it would be really fast. That you would be right back. Period. Oh, yeah. You're welcome. Okay. So we've either got one of these two things going on. It doesn't matter what the power is. In fact, it could probably be an n minus 1. It would mean the same thing. But typically we see there's the n or n plus 1. The key is you've got a negative 1 in there. Or you've got like a negative 2 that you could rewrite as negative 1 times 2. Okay? And that's the kicker that gets it to alternate. Okay, so it will make it alternate signs. So either it's going to start positive, that's the n plus 1, or it starts negative, that's just the n. So you'll probably see a lot of n plus 1s because mathematicians like to start positive, right? All right, so for alternating series, we have to prove two things. Okay, we're in one of these two formats. Okay. And it will converge if it has, so you know it's alternating because you're in one of those two formats. Okay, that's like the if part. We got those two formats, great, alternating. Okay, now we just determine convergence. So the limit as n approaches infinity of a sub n equals 0. So you have to have that limit equal to 0. And the terms have to, what do you think this means? Look at it says down here, non-increasing. What does that really mean? This is talking about the terms decreasing. So decreasing terms. There are a couple of ways that we can prove that. We could, like we were doing with the integral test, we could do it by showing the first derivative. Or we could just actually list out the terms and see if they're decreasing, just like we were doing on the comparison test. Okay, so I'm probably going to take approach 2 this time rather than doing a lot of derivatives. But there was a side note here, wasn't there? Alternating series test doesn't show divergence. Okay, if you put it into here, which isn't that the nth term test right there? If I put it into there and it doesn't equal 0, it does diverge, but it diverges by nth term. Okay, not by alternating series test. So if you ever see one of the multiple choice questions that says diverges by alternating series test, you know that that's not true. Okay, you can never diverge by alternating series test. Okay, all right. We already know the answer. Well, we kind of know the answer. Doesn't that look harmonic right there? What makes it not harmonic? Yeah, this part here just made it alternating. Okay, so I've got to deal with alternating. We're gonna start. So I already know I'm doing alternating because of the negative 1. I'm gonna test my two conditions. Okay, so the first thing I have to show or try to figure out is the limit as n approaches. It's been doing that all day. As n approaches infinity of 1 over n. I ignore the negative when I do this part. Okay, I think did it say that here? Did it say, oh, it didn't say absolutely. It just said a sub n here, right? It didn't say this part. It just said the series inside. Okay. All right, so when I put an infinity in there, so I get 1 over infinity, what's that equal to? Part 1 check, right? We got it equal to 0. I now need to prove that terms are decreasing. Okay. So second thing, I'm just going to start putting in terms and see what happens. I'm going to make a list. So I'm starting with putting in a 1. So 1 over 1, I'm going to put in a 2, 1 over 2, 1 over 3, 1 over 4, 1 over 5, and so on. Are the terms decreasing? Yes, decreasing. And we're ignoring the negative, the alternating sign, right? So are the terms in a decreasing order? Okay, so this just showed that we know that 1 over n plus 1 is less than or equal to 1 over n. That means that my next term is less than my previous term, okay? For all, this is the proper math way to write it, for all n greater than or equal to 1, which basically that's a statement, a fancy math statement that says, hey, the terms are decreasing. Okay, so I proved my two things. What does that mean about the series? Does it converge or diverge? It only can do one thing, right? It only can converge. So therefore, the sum, and again, we're writing out the fancy way today, right? The sum as n equals 1 to infinity, negative 1 to the n over 1 over n converges by alternating series test. This is one of the few that they abbreviate. I wouldn't if I was writing out the reason. I would write alternating series test out on the AP exam. I'm being super lazy right now. Okay. The next one's interesting. Let's take a look. All right. How do we know we're using alternating? It's obvious, right? It has that negative 1 in front, right? I'll get it. So we know we have to use alternating series tests. All right, so let's start with our limit as n approaches infinity, right? So that's step 1. And this step 1, step 2 thing, that's a Mrs. Ballard thing, okay? It's limit as n approaches infinity of the natural log of n over n. Okay, if I put infinity in the top and the bottom, what happens? What do I get? Oh, infinity over infinity. What's that called? In what? Not inconclusive. Indeterminate. Right? Which you never actually have to use that word on the actual AP test, but I want to make sure you're smart for next year's professor, okay? All right, so indeterminate. Am I allowed to so what do I have to do if I'm indeterminate to take a limit? I need to apply a rule. Whose rule? Yeah, we got to do L'Hopital's rule. Okay? Because I'm going to try to, I still want to be able to take that limit. All right, so what's the derivative of natural log of n? Good, what's the derivative of n? 1. Now when I put in infinity, what's the limit equal to? Which is what I wanted, right? I wanted it equal to 0. Woohoo, we've got step 1 done. I just got to prove terms decreasing. That might not be as easy this time. I know what natural log of 1 is. Do you all know what natural log of 2, natural log of 3, natural log of 4, natural log of 5 are? No. Okay. So here is a situation where we probably have to apply the actual first derivative test. Okay. In this one, I could totally tell by just listing the terms, right? So I got away with it. This one, I can't get away with it. So sometimes we need to use some of our other tools. We're going to have to use the first derivative test. Just because we like F's, I put it into F's when I did it before. So f of x equals the natural log of x over x. You don't have to do that. If you like n's, use the n's. It does not matter. All right. So we're going to find the first derivative. And we're going to try to figure out if it is positive or negative here. Okay. What rule am I going to need to do for this first derivative? Quotient rule. It's a good thing we've reviewed that recently. All right, derivative of natural log of x. 1 over x. And then keep the green, right? Use some subtraction. Keep natural log of x. What's the derivative of x? 1, and then all over x squared. Okay, I know those cancel, so I've got 1 minus the natural log of x over x squared. I'm going to try something different than what I did before. I did a whole huge sign chart and everything, but I think I can do this without that. We want to know where it's decreasing, right? Couldn't we do the same thing we did with integral test and force it to be less than 0? Let's try that and see what happens. think it ends up getting me the same place it did when I was doing the other. Maybe not. Okay. What is, so I multiply that over. So we got 1 minus natural log of x is less than 0. Could I move the natural log of x over? So 1 is less than natural log of x. All right, how do I get rid of the natural log? E, so I've got to exponentiate. We haven't done that in a while. Ooh, this is a good problem. Done like 6 things we haven't done in a long time. All right, E, oh, and I just switched my symbol, didn't I? It should be a less than. Less than. All right, E less than X. So okay, this actually works the way I wanted it to. All right, so as long as X is greater than E, we're decreasing. All right, so ultimately what that means is it eventually trends towards decreasing, right? Because where does my series start at? 1. This is like at 2.7. So for a little bit, from 1 to 2.7, it's not decreasing. It's probably increasing or constant, right? So, but it's after 2.7, it decreases. So it trends to decreasing. So did we pass our alternating series test? Yeah, it passes, right? So does it converge or diverge? Converges. Good. So therefore, the sum as n equals 1 to infinity of -1 to the n. All I'm doing is copying my original series notation down. Okay. Okay. Converges by alternating series test. And I'm going to be specific about the interval for n. I'm switching it to an n instead of an x because that's what our series is in. For n greater than e, it really does converge for the whole thing because it trends towards that decreasing. All right, that's where we're going to stop today because there's no way we'll get through one more. Okay. All right, we will do quiz and probably a little bit more on these notes tomorrow. Okay.